Hello there guys, welcome back to another epic inexorable maths video. In this video we're in a new top secret location and we're using a blackboard for the first time. This is kind of crazy. In this video we're going to differentiate some hyperbolic functions, namely sine and cosh, okay? So these are really nice. These are even nicer than differentiating trig functions like sine and cos, because sine and cosh just differentiate to the other one respectively. So sine differentiates to cosh and then cosh differentiates to sine. So basically any even derivative of either of them is just the same thing, and any odd derivative is just the other one. So like the 101st derivative of sine would be cosh, we just know it. Is even easier, as I say, than trig functions where it goes sine and then cos, and then when you differentiate cos it goes minus sine. None of that happens, no negative signs ever. It's just they differentiate to each other. So we can really easily show that just by taking their exponential definitions and differentiating them. So if we differentiate what is basically sine, e to the x minus e to the minus x over 2, this is the definition of sine. Let's see what we get. So, you know, it depends how you want to do it. You could probably factor the 2 out. So I'll do a half here, I'll factor the half out, and then we'll differentiate e to the x minus e to the minus x. And e to the x differentiates to e to the x, minus e to the minus x differentiates to plus e to the minus x via the chain rule. And we can see here that if we put the 1/2 back on the bottom there, we will get this is equal to e to the x plus e to the minus x divided by 2, which is precisely the definition of cosh x. Amazing. Okay, now let's try it with cosh. So, cosh x, let's try and differentiate that. So cosh is e to the x plus e to the minus x divided by 2. Okay, let's differentiate it. Well, I'll show you guys that there. So, okay, let's differentiate this. Again, factor the half out, so we've got 1/2, and then we're going to differentiate e to the x plus e to the minus x. This is really easy, guys, because e to the x differentiates to itself, so we have e to the x here, and then plus e to the minus x is just minus e to the minus x, again, via the chain rule. And then we can see that this is just e to the x minus e to the minus x divided by 2, which, as you may know, is sine x. Amazing. So they differentiate to themselves. Perfect. And that's basically it. Just like always, the rules for the chain rule still apply, the rules for the product rule, the quotient rule, all of these differentiation rules still apply. So for example, something like if we wanted to differentiate sine of, let's say, 2x, the normal way that you would do this, you probably use the chain rule, the 2 would have to come out and you would get 2 cosh 2x, just to kind of explain what I mean. So you can't ignore the chain rule and everything. Still, it still applies. Hope this helps.